The SR NOR flip-flop. The SR NOR flip-flop, or SR NOR latch, is the first circuit we will examine. This block diagram shows the SR NOR flip-flop has two inputs and two outputs. The inputs are labelled S for set and R for reset. The outputs are labelled Q and Q0. Q0 is the inverse of Q. The SR NOR flip-flop is made from two NOR gates. The output of each of the NOR gates is connected back to the inputs of each opposite NOR gate. The truth table for this circuit is as follows. When S and R are set to 0, 0, Q and Q0 will remain in the same state. When S is 1 and R is 0, the flip-flop is in set condition, setting the output Q to high and Q0 to low. When S is 0 and R is 1, the flip-flop is in reset condition, setting the output Q0 to high and Q to low. If S is 1 and R is 1, the flip-flop will go into invalid condition. This is not used. We can't set and reset the device at the same time. We can now go over to the simulator and test the truth table to view the outputs. Here we have the SR NOR flip-flop set up in the simulator. An input switch has been added to the S and R inputs. A green LED at the Q output and a red LED at the Q0 output. When we start the simulation, the red LED is lit. The flip-flop has started in reset condition. Both inputs are at 0, 0, so the condition will remain until it is changed. So let's input a 1 to set. The red LED goes off and the green LED turns on. Q is now set to high and the flip-flop is in set condition. If we now input a 0 on set, the green LED remains on. The flip-flop is in no change condition and we will still have a high signal on Q. If we now put the reset input to 1, the green LED turns off and the red LED turns on. Q0 is now high and the flip-flop is in reset condition. And turning reset back to 0 tells the flip-flop to remain in this condition. It is now in the no change state once again. If we now set both the set input and reset input at the same time to a 1, there is no output from Q or Q0. It outputs an invalid condition and should not be used. When students first encounter flip-flops, it can be difficult for them to grasp what practical use they have. By switching between set, reset and no change, we can send a signal to the flip-flop and it will remember the last state it was given. We can also use the waveform viewer to examine what condition the outputs are in. Here we can see the waveform for set, reset, Q and Q0. When we started the simulation, both set and reset were at 0. Q was at 0 and Q0 was high. This was the condition when the flip-flop was turned on. We then changed set to 1 and reset to 0. Q changed to 1 and Q0 to 0. We set the flip-flop. We then changed set back to 0, and with reset also at 0, the flip-flop was in hold condition. Q and Q0 remain in the same state. The flip-flop will hold this setting until a change is made. We then changed reset to 1, set at 0, Q changed to 0 and Q0 to 1. The flip-flop is in reset condition. Finally, we changed reset back to 0 to hold the circuit in the current state. Let's now go back to the simulator and look at a practical application for the SR NOR flip-flop. Here we have a circuit using the SR NOR flip-flop, which will help us better understand how it can be used. In the centre we have the SR NOR flip-flop. We have an input switch at both set and reset. At the Q0 output there is a green LED and a current limiting resistor. The Q output is connected to the base of an NPN transistor. We have a 5V power supply connected to a red LED and current limiting resistor. This then connects to the collector of the transistor. The emitter is connected to ground. This circuit is to simulate how we could use the flip-flop as a type of proximity alert device. The input switch on the set input would be a passive infrared component, which would input a signal when someone passed by it. It will remain in this state until the device is reset. When we play the simulation, the green LED is lit. The LED provides an indicator that the device is OK and the PIR has not been triggered. When someone passes the device and triggers a 1 signal to the set input, Q goes high, turning on the red LED and alerting the user that the device has been tripped by a person entering the area. The green LED is now off. Notice that it now does not matter how much we turn set on and off. The device will remember that the sensor has been triggered, and it will remain in this state until reset is turned on and the green LED is lit again. The red LED could be replaced by a high decibel siren to give an audible indication that the alarm had been triggered, and it would remain on until reset was switched back on.